So here we have convert the decimal number 16 into a binary number. So remember, to convert into a binary number, we're only allowed to use zeros and ones. So in a base 2 system, a binary system, if you will, we're only allowed to use zeros and ones. So, but we also have a different place value chart. So remember, we have 2 to the 0, which is the ones place. We have 2 to the power of 1, which is the twos place. We have 2 to the power of 3, 2 to the power of 2, which is the fours place. 2 to the power of 3, which is the eights place. 2 to the power of 4, which would be the 16th place. And then 2 to the power of 5 would be the 32nd place. So if we look at this 16, if we look at our place value, we want to figure out how far out can we go. Well, notice that 16 would actually be 1, 2, 3, 4, the fifth place out. So 116, and then if I turn everything else to zeros, 1, 0, 0, 0, 0. So 1, 0, 0, 0, 0 means 116, no eights, no fours, no twos, no ones. So that would represent 16 in the base 2 system. Now, to just do a different one as another example, since that one was so easy, if we wanted to say convert, say 84 to a binary number, this one may require a little bit more work than that one did. So just in case you get a little bit harder one. So again, if we have 2 to the 0, that's the ones place. 2 to the power 1 is the twos place. 2 squared is the fours place. 2 cubed is the eights place. 2 to the fourth is the 16th place. 2 to the fifth is the 32nd place. 2 to the sixth would be the 64th place. And 2 to the seventh would be 128th place. Notice I had to go a little bit further because 84 goes out pretty far. But notice that I can't use the 128 because it's too big. So the question is how many 64s can I get into 84? So you have to actually use a little bit of division here. So 64 goes into 84 with the remainder of, it'll go one time, and 64 minus 84 minus 64 would be a 20. So right now what I can do is I can pull a 64 out by putting a 1 here. So that just leaves me a 20. To do a 20, 32 is too big, so I have to put a 0 there, so I can do 16s. So how many 16s can we get into 20? Well, we can only get 116 into 20. 1 times 16 is 16, and 20 minus 16 is 4. So we can do 116. Notice our remainder is now 4. So I can't use 8s, but how many 4s can we use? So notice that 4 does go into 4 one time. So 4 goes into 4 one time. And notice that the remainder would be nothing else. So we don't need any 2s and we don't need any 1s. So what I do need is a 64, a 16, and a 4. And that would add up to this 84. So 1, 0, 1, 0, 1, 0, 0. That would be the binary number that would represent the decimal equivalent of 84. So there's some food for thought. There's probably some cleaner ways of doing your division. That's the harsh part, is trying to keep your division organized. So just keep that in mind. This could probably be done a little bit quicker. You can probably look on YouTube and find some more organization on your division there.